Welcome to Learning with Philemon. In this video, we will be looking at how to calculate the concentrations of solutions and how to use concentration in stoichiometry calculations. In the last video, we looked at stoichiometry calculations involving gases. Concentration C can be calculated using the equation C is equal to moles N divided by the volume of the solution V. The unit of concentration is mole per dm cubed. Concentration can also be calculated using the equation mass m divided by volume. The unit of concentration using this equation is grams per dm cubed. In this diagram, we have two beakers containing different amounts of a chemical dissolved in the same volume of water. On the diagram on the left, we have less moles of the chemical than in the diagram on the right. Therefore, the solution on the left is less concentrated than the solution on the right. Solutions of low concentration are also called dilute. Let's see how these equations are used in practice using the following question. What is the concentration if 0.5 moles of hydrochloric acid, HCl, are dissolved in 10 decimeters cubed of water? Substituting in the values into this equation, we get the following calculation. The concentration of the solution is 0.05 moles per dm cubed. If you want to write the concentration in grams per dm cubed, you must multiply by the molar mass of the chemical. The molar mass of hydrogen chloride is 36.5 grams per mole. Note that when multiplying concentration and molar mass, the units of mole cancel out. The concentration is equal to 1.8 grams per dm cubed to two significant figures. This means that there are 1.8 grams of hydrogen chloride dissolved per 1 decimeter cubed of water. As we saw, to convert from mole per dm cubed to gram per dm cubed, we multiply by the molar mass. To convert from grams per dm cubed to moles per dm cubed, we must divide by molar mass. Now let's see how we can apply this to chemical equations. A typical question would look like this. 10 centimeters cubed of 0.1 mole per dm cubed sulfuric acid, H2SO4, is required to react with 25 centimeters cubed of sodium hydroxide, NaOH. What is the concentration of the sodium hydroxide solution in mole per dm cubed? This reaction is a neutralization reaction between an acid, sulfuric acid, and an alkali, sodium hydroxide, producing a salt, sodium sulfate, Na2SO4, and water, H2O. You will see more of these types of reactions in the acids and bases playlist. Stoichiometry questions usually involve 3 steps. For a recap on this method, please watch the video Masses from Equations. In the question, we are given the volume and the concentration of sulfuric acid. We can calculate the moles of sulfuric acid by rearranging the equation we saw previously to N is equal to C multiplied by V. Substituting in the values, we get the following calculation. Note that as the concentration is given in mole per dm cubed, we need to convert the volume from centimeters cubed to decimeters cubed. There are 1,000 centimeters cubed in 1 decimeter cubed. Therefore, we divide 10 centimeters cubed by 1,000. There are 0.001 moles of sulfuric acid. The second step is to figure out the number of moles of sodium hydroxide required to react with sulfuric acid. There's a molar ratio of 1 to 2 due to the coefficients. Multiplying the moles of sulfuric acid by 2, we get 0.002 moles of sodium hydroxide. In the final step, we can calculate the concentration of the sodium hydroxide solution. We calculated that there are 0.002 moles of sodium hydroxide. The volume of sodium hydroxide solution in the question is given as 25 centimeters cubed. This is equal to 0.025 decimeters cubed. The concentration of the sodium hydroxide solution is therefore 0.08 moles per dm cubed. A common issue for students is mixing up the values for each species. I recommend underlining the values in the question and writing them under the correct reactant or product as seen here in the equation. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.